We keep working on binary trees of numbers, so let's try a binary tree of structs. We'll start with a simple struct representing an employee. So define struct employee as having a name, title, and pay. And an employee is a make employee with a string number. That pay is going to represent, pay in tens of thousands. So if you have 40, you'll have 40K. We can make a quick example of an employee. We'll hire Ada as being an employee. Her name is Ada Bart, and she is a corgi, professional corgi. And we'll say that she earns about 170K per year. So she's a pretty good employee. Now we'll need some examples of something more sophisticated. We're going to make an actual company by using our node definition from before and our new employee definition. So we have a company where a company is a binary tree of employees. We'll define a small company, this is a constant, by making a node with an employee inside of it. In this case, the employee is Alice, her title is boss, and she makes 100K per year. She has 2 employees. The first one is Bob, Alice's secretary, who makes 50K per year and has no underlings under him. Then her other employee, Alice's other employee, at the top level, is Carol. Make employee Carol, who is her apprentice. Makes 70K. And Carol, being just an apprentice, doesn't have any employees under her. And that's the entire company right there. So this is a pretty small company. Alice is the boss, and her 2 employees are Bob and Carol, neither of whom have employees under them. Let's make a more complicated company where the grunts are not paid very well. So this time we'll make big company. Big company. This is a make node. The top of the hierarchy is our lovely employee Ada. She is a CEO and makes 600K per year. Very good dog. Then we'll make another node, and this will be Ada's first branch of employees. Over on one side of the company, she has Bill, who is the VP of marketing, and he makes 120K per year, has a couple employees underneath of him. The first one is Chuck. Chuck is just a lowly grunt, and Chuck only makes 40K. The other employee, and so Chuck doesn't have any employees under him. But Bill has another employee. This employee is David, who is also a grunt and only makes 42K. David doesn't have any employees under him either. That was one wing of the company. On the other side of Ada's company is Aaron, who is the VP of sales and makes 140K. Aaron has only one employee underneath of her, and that is Fiona. Fiona is also a grunt and makes, we'll say, 45 and has nobody under them, and Aaron only has the one employee. So that's our big company. We got our small company and our big company. Let's say a good company is one where everyone is paid well. In this case, we'll say that making 50K or more per year is being paid well. We can write a function to test if a company is a good company. And a company without any employees will be a good company by definition. Now to smooth out some of our logic. So, good company is a function, consumes a binary tree of employees, aka a company, and produces a boolean. Consumes a binary tree of employees, produces a boolean indicating whether or not they are all paid well. Define good company, as being a binary tree. Consuming a binary tree. Does something, ... And let's write check expects. Good company, on an empty company is by definition true, we said. Good company of the small company, where everyone makes at least 50K, is true. And then for our big company, there are a bunch of grunts who don't make a lot of money, and that means that the result is false. When we start actually implementing this function, we start off by going to copy our template. We always get to get some kind of template in here. Saves us a bit of time and effort. In the case of an empty company, we know that it produces true. We come down here and we have our node value. We need to find out something about the current employee that we're looking at. And we'll ask then the question, is the left side of the company good and is the right side of the company good? We'll need some way of combining all of them together. Notice the phrasing I used there. Is the left side of the company good and the right side of the company good? We need to make sure that all parts are good. So we're using the AND operator and checking to see if this is good and this is good and this is good. The node value is an employee, and we're really asking the question about employees. Is the employee's pay greater than or equal to 50? That was how we defined a good company. So we'll say if the employee's pay is greater than 50. Then we'll say true based on if it is and false if it isn't, anding that with the result of the left side of the company and the right side of the company. And assuming that passes all of our unit tests, we need to remember to use the same variable throughout when we copy our template. Easy mistake to make. Okay, yeah, that was our good company function. So you see we did some Boolean accumulation. We used the greater than or equal to operator and the AND, combining multiple pieces, multiple recursive functions into one.